This is the report out for group number 1. We talked about patents and annotating patents. Part of the discussion was we talked about what the tool at Harvard does, so that was very helpful to learn about what Domio does. I think is that the official name, Domio? So thank you for that. In the rest of the discussion, we talked about the key features we need for a patent annotation tool. Some of them might be technologically challenging. So the first one is we need to be able to handle dynamic content. So patents that are returned in a search. So let's say a user searches for some words and then a few patents are returned, and then they want to fetch those patents and annotate them. So it needs to be, the annotator needs to be able to handle completely dynamic content. Then there may be multiple users. So somebody else does a different search that returns some of the same patents that were previously annotated by another person. So then that person's annotations need to be added on as well. But everything's fairly dynamic in terms of what content is returned and who, as response to what users search. The third main feature is creating a semantic graph of each patent. So you start by identifying kind of the highest level elements inside a patent, annotate them. Then you go look for the second and third level elements and annotate them as well, so that you're capturing kind of the semantic model for that patent. So those were the three main features that we figured are important. I think that is about it. Thank you.
Thank you. Group number 2, we talked about the questions around resource equivalence or document equivalence, and I think the only real determinations we made were that this is a really hard problem. There are both human solutions and automatic solutions, and among the automatic solutions, there is a tendency for them to be very domain specific. So obviously the way that Shazam fingerprints music to determine what song you're listening to is maybe different from the way you determine whether two papers coming from two different archives might be the same. And then we identified that the problem can be broken into two parts. One is determination and one is coding. So assuming that you've determined there is some relationship between two documents, how do you code that? This ontology called the ORCA, Ontology of Reasoning, Certainty, and Attribution, was brought up as a potential best maybe existing taxonomy of relations for this kind of thing, whether these are equivalent resources, similar resources, critiques of one another, or something like this. And so that's about all we got.
We talked about annotating geographic areas or making geographic annotations. We got together an awesome number of 4 people in the table, and we were first introducing which use cases we knew about. So we talked about annotating climate data, scientific data, talking about annotate things outside the Earth, like in the solar system, or maybe annotating data to point errors of previous annotations that have been made, maybe mixing up latitudes and longitudes. We talked about existing solutions that are similar to what we want to accomplish but are not standardized yet, like GeoFacets or MapHub. We also talked about what else? Which is the minimum amount of data that we need to reference a region. So we need latitude, longitude, depth. We need to know perhaps the coordinate system to make these annotations. We also talked about annotating geographically, annotating geographic data versus making geographic annotations about data, saying that we can annotate the text and say this has been annotating, well, this is related to this area of the world, for example. We were also talking about how images and maps are not the same, and we cannot use tools that already exist to annotate 4-dimensional or 3-dimensional images for our use cases on maps. And, well, I think I don't know, maybe I'm forgetting something. This is all, I think.
Okay, I hadn't realized that we were going to report, so here are some disjointed thoughts. We began with a discussion of critical thinking theory and with an idea to bring the layers of critical thinking theory into an annotation software as in a palette or an importable collection of tags that could be used. But then we followed out the logical, educational, pedagogical implications of that and realized that we really need to have many more resources to guide the student to use these ideas appropriately. So we discussed schematizing, as in creating a schema as schema.org, and having a controlled vocabulary of critical thinking terms, as I presented earlier this morning, that students could find the definition of. They could find examples from classrooms, they could find examples from intellectual work across history. And so we concurred on, I think there was concurrence on the idea that we can't code out improper use of critical thinking terminology, but maybe there was more optimism that we could develop a user interface that could have some safeguards or bumper lanes to get us further down the lane than we might otherwise if we were just on our own. But there's obviously still much to do to code critical thinking theory into annotation software.
So Group 5 talked about readability issues with introducing annotation. So reading a document on a computer is already its own nightmare in terms of formatting, but how do you bring in an annotation and make it a seamless reading experience? Is it a pop-up? Is it a sidebar? Is it something that expands and is then collapsible? We also then got into colors. So right now a lot of people use sort of highlighter effects to indicate where some text has been annotated. So are there different colors? What if you're colorblind? Do you want to use an underline? That indicates you're linking something. Do you want to use a line on the side? Then you can't get down to an individual word annotation. So just how do we think about indicating to a user that there's been an annotation made without completely disrupting the user experience? Maybe there's a layer where you can read it without the annotation. And then we got into, if mobile is the new frontier, how do you annotate on mobile? How does that look? Is it a sidebar that swings in? Does each annotation have its own page? Obviously, pop-ups are terrible on mobile. So lots of things to think about in terms of how we actually bring the annotation to the user.
So Group 6 talked about mathematics annotation. We started by trying to think of issues that might be particular to mathematics annotation and questions. So for example, are there some unique challenges to anchoring your annotation to the mathematics in the document or resource being shared, given how poorly mathematics is often represented in web documents as graphic as opposed to being broken down like words tend to be. And you need to be able to annotate math at a very fine granularity and to layer mathematics annotation. We talked about issues of what are the sources of controlled vocabularies, the ontologies that Eric alluded to that would make math annotations more useful and allow you to do things with them. The ideal goal would be a suite of computational annotation tools that have the fluidity of sitting down in a room by yourself with a pen and paper, but can also bring to bear the power of computational systems as you go without interrupting your thinking, without the tools getting in the way. Ideally, the computational issue would step in at the right time and fill in the next 3 steps in your proof, but still allow you to think and really do the kind of analytical work. In general, it should be easier to add great mathematics on the web as well as annotate it. One of the challenges in mathematics is the nomenclature syntax convention can be very challenging because it varies even in close related domains. Does math annotation become more or less useful as the audience for annotations advances? Is it more important for undergrads or for a senior research mathematician? And there's a progression here that maps directly on the progression of the fields. So highly axiomatic fields and more concrete fields in mathematics tend to be easier to annotate. And then a few kind of random comments. There's tension in the tools, diametrically opposed goals of lowest impedance for the task of writing and annotating math, but at the same time being able to be clear, complete, and unambiguous. Tools have a hard time disambiguating use of math syntax because the tools don't really understand the domain context. As you build up a database of annotation, the machine might learn and do better job of recognizing us, which emphasizes the importance of thinking of math annotation as a collaboration between automated systems and the human. But there are some important uses for this. For example, a kind of use case that's fairly obvious is a student might want to find examples of proofs by induction within the number theory literature. You can find number theory literature, find out that there are proofs by induction within that paper, and find out where in the paper they are is actually kind of hard right now. So there is a need for this going forward.
All right, I'm going to try and summarize what was very intensely packed. It was talking about annotation for cultural heritage and cultural heritage institutions, something which I think probably encompasses everything, considering science, law, art, documents are all cultural heritage. So what seemed to be the thing most interesting to people were the possibilities or the need for interoperability of media types for both meaning and analysis. So we talked about transcription, tagging, semantic markup, and then annotation as interpretation and understanding. But the difference here is that very often people are annotating metadata itself, that when you catalog something, which we've done for a long time, you're actually adding both metadata and interpretive understanding. Metadata itself, as a concept, being somewhat contentious, I learned, as is anything being immutable. I guess nothing is. So capturing disagreement is absolutely critical in the idea of annotation, that the annotations and preserving them captures the disagreement and change in understanding over time. Location-based annotations was also very important. Annotations themselves having locations the same way objects do. So the time and place at which you might annotate the metadata of an object, annotate your understanding of it, be it in the field or back in the museum or in a lab. Especially important was the discussion on access, and that's both accessibility and access for why are we preserving these things? What's the goal in annotating any of this? So one of the critical goals, Phil is working at Harvard, talking about cultures that are being lost and actually preserving as much as we possibly can, and that includes annotating and adding the metadata for things while we actually have the knowledge, but then providing access for the future. And that was kind of where we left it off. How do we not screw this up for the future, being as technology and understanding are moving targets?